Now eventually you're going to have to deal with logarithmic equations, and sometimes you have a few interesting looking problems, especially with just simple terms. Now, here are some properties to help you clean them up. If you've got a log to a base, and you've got another number to a number, we'll say g, then this is equal to having g times log base b of x. If you've got a logarithm to a base b with two numbers x times g, then that's equal to the log of base b times of x plus the log of base b times g, of g. Now, you've also got another set of properties. If you've got a log to a base where there's a number over another number, this becomes the logarithm base b of x minus the logarithm of base b of y. And then you've got another one, which is to say logarithm of base b to the x is equal to logarithm base b to the y. Now, here's the thing. Since this is a logarithm b to x, this is logarithm b to the y, this is actually going to cancel out, and it's just simply x equal to y. Now, these will be able to be used to get simplified versions of your more complex logarithms, and this will help out in your equations. Now, your equations include doing something like this. If you've got logarithm of x squared equal to log x squared, this becomes log x squared, and this is log x times log x. So that becomes log x squared. Or you can get a problem such as this. Finding the x of log x plus log of x minus 15 equal to 2. Now, using what we know of the properties, we reverse this. So, this becomes log x times x minus 15, because if you've got a plus between these two logs of same base, it's going to be log xg is equal to log of x and log base b of g. So this goes and becomes 2. Then you've got x squared minus 15x equal to 2. Guess what? This is similar to a quadratic equation. So by doing these quadratic equations, we will notice that log base 10, you've got log base 10 to the squared power is equal to x squared minus 15x. Because when you've got this, since this is log base 10, it's going to take your base to this number as an exponent, and it'll be equal to this. So we just take that and turn that into 10 squared equal to x squared minus 15x. 100 is equal to x squared minus 15x. Continuing on, from here I think we'll do it in the quadratic formula and go a is equal to 1, b is equal to negative 15, and c is equal to 100, or negative 100, because we're going to subtract that and put it on this side. So that means that negative 15, so I'll just simplify that to 15 plus or minus the square root of negative 15 squared minus 4 times 1 times negative 100 all over 2 times 1. And so this becomes 15 plus or minus the square root of 225 plus 400 over 2. Then that becomes 15 plus or minus the square root, I think I'll just simplify that down already, plus or minus 25, because 625 is a perfect square of 25, and put it over 2. So we've got 20, which is 15 plus 25 over 2, 40 over 2, and that is equal to 20. And then we've got 15 minus 25 over 2, negative 10 over 2 is negative 5. And so those are the factors, your x-intercepts, your y-intercepts for the, it is your x-intercepts for that particular equation.